Hi everyone, Mr. H here. This video is about how to graph a parabola in Vertex Form. Now up to this point we've looked at some transformations on Desmos, but one of the things we probably haven't connected all the dots on is just figuring out how we actually do this by hand. How do we figure out what key points are on a graph? And so that's what we're going to do in this example, or two examples we do today. One of our goals is to describe the transformations in words, which hopefully you're getting comfortable doing now. But the second thing we're going to do is graph a parabola in Vertex Form by hand. And we're going to do that by two different steps. We're going to start with y equals x squared. So the first step is then going to be apply the a value, and then we're going to apply that vertex, h and k. So let's see how that actually works here. The first example says, describe the transformations applied to y equals x squared to graph y equals negative 2x squared, then graph it. So let's do that beside the grid. And we know that there the a value, if we're going from y equals x squared to y equals negative 2x squared, then the a value is negative 2. And there's no h value and there's no k value. Those are just 0 because we haven't gone x minus a number or plus a number in brackets, and we haven't added or subtracted anything at the end. So the a value being negative 2 simply means that it is being vertically stretched. It's a vertical stretch by a factor of 2. It's a stretch if it's bigger than 1, if it's a compression if it's a fraction or a decimal that's less than 1. And then the negative part of that makes it flip it over the x-axis, flips or reflects over the x-axis. And so we're going to start here by graphing y equals y equals x squared rather. So here's my y equals x squared. And you should be very comfortable with these points. You should really get to know these points super well, because these should just be second nature once you get going in this unit. That we have, if we're graphing the line y equals x squared, that 1 squared gives me 1, 2 squared gives me 4, and then they're reflected about this this axis of symmetry right in the middle. And so that is the graph y equals x squared. Now what we're going to do is we're going to apply to that graph the different transformations. And the first thing I'm going to try to do is I'm going to apply this, just the vertical stretch by a factor of 2. The vertical stretch by a factor of 2 means that I am going to double the y values, right? Consider this equation for a minute. If I have y equals 1 squared, x squared, if it's 1, well, that would give me just 1. But if I have y equals, just ignore the negative for a second, but if I have y equals 2 times 1 squared, well, that gives me 2. So whatever I had here, it gets doubled by that 2 in front. So we're going to take each of the y values and we're going to double them. So I'm going to double that, so 1 becomes 2, 1 over there becomes 2. 0 stays at 0. 2 was 4. That value is going to double. It's going to become 8. So instead of 4, we're doubling 4 up to 8. The same thing with the other side because of the symmetry. And then we can draw this. This line that I'm drawing right now is not the final result because we haven't flipped this over the x-axis yet. This is the line y equals 2x squared. So we've doubled all the y values. The x values haven't changed at all. That's a really important point. I'll say it one more time. Double the y values don't affect the x values. So you're not making this skinnier. You don't make it wider if your a value is less than 1. You are vertically stretching the values. You are doubling, or if it's a half, you would half the y values. The x values stay the same. So now we need to go ahead and we need to apply this negative part to it. And this negative part says it's going to reflect over the x-axis. So we have the y equals 2x squared, and we're just going to reflect all the 5 points on that curve down over the x-axis. And so what we're going to get here is this. We've doubled them all, so we get negative 2 and negative 8 when we have negative 2 in the x values. So our curve is going to look like this. This is the line y equals negative 2x squared. Now, I would expect as you get comfortable with this that you can jump right from y equals x squared directly to y equals negative 2x squared, as we're going to do it in the next example. But that's just to walk you through, so hopefully you see how those vertical stretches are actually being applied. All right, the second example says this. It says, describe the transformations applied to y equals x squared to graph y equals negative 1/2 x plus 3 squared plus 4, then graph it. So let's write that down here below. Y equals negative 1/2 x plus 3 squared plus 4. Now keep in mind that what we're comparing this to is our vertex form, which says ax minus h all squared plus k. And so because of that, we should be able to tell that the a value is negative 1/2. We'll talk about what that does in a second. But we should also see that the h value is negative 3. Well, why is it negative 3? Well, consider this equation again here for a second. If I take this equation and I rewrite this, I could write this as negative 1/2 x minus, because the general form is x minus negative 3 squared plus 4. So if it's in that general form where we have that minus sign, that must mean that h is a negative 3. And so because of that, it's going to be negative 3. It's going to shift it to the left, as we'll describe in a second. And the k value is going to be 4. All right, so the a being negative 1/2 is a vertical, not a stretch in this case because it's less than 1. It's a vertical compression by a factor of 1/2. So we're going to multiply the y values by 1/2. Then we're going to do this, before we do the h, we're going to do one more thing. We need to take into account the negative. The negative flips it or reflects it over the x-axis. Now some of you might mix that up and say it reflects over the y-axis. Reflecting over the y-axis doesn't do anything because it's initially, the original parabola is symmetrical about the y-axis. So it's important we say it reflects over the x-axis. All right, so this h being negative 3 is going to shift 3 units left. I already described how we got that negative 3. And the k being 4 is going to shift it 4 units up. And so we go to our graph, and I'm going to start with blue again here. And here is the first y equals x squared graph. You have those 5 key points. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And this is the graph y equals x squared. And it's important we label every single one along the way. Otherwise, it might get a little cluttered and confusing. The second thing I'm going to graph here is the line y equals negative 1/2 x squared. So I'm going to start with y equals x squared, then negative 1/2 x squared, and then I'm going to graph the final result. And so if I'm applying a 1/2, what that would do, I'll think about the negative here in a second, but 1/2 would make all these values half, right? So you take all the y values and you'd half them. So if you had a y value of 1, it would become a half. If you had a y value of 4, it would become 2. And if you had a y value of 0, it doesn't change at all. Now, it's negative a half. And so I told you in the last graph that I would try skipping this step in the future as we get comfortable with it. So that's what I'm going to do here. We're going to take those points that are half, and we're going to flip them down below. And so if I flip those down below, what I'm going to get, flipping over the x-axis, is that 1 is going to become negative a half, right there. Same thing on the other side because of symmetry. And then that 4 is going to become negative 2. 4 is going to become negative 2. And so 0, 0 still exists, and so we're going to have a graph that looks something like this. So now we've applied the a value, negative 1/2 x squared. And now that we've applied the a value, now we're going to graph the final result. And the final result is going to be shifting 3 units left and 4 units up. We're going to take all 5 of those points, shift them 3 units left, 1, 2, 3, and 5 units up, 1, 2, 3, 4, 5. So there we go right there. And then from that vertex, we went over 1 down a half. So we're going to keep the same shape, over 1 down a half. Over 2 down 2, over 2 down 2, just like that. And that is a graph of y equals negative 1/2 x plus 3 all squared plus 4. That is how you need to graph these in this course. You need to start with the y equals x squared, remembering that you're going over 1, up 1 from the vertex, over 2, up 4 on both sides. And then you're going to apply the a value, and then you apply the vertex from the a value. So you should always have those 3 curves on every graph that you graph in this unit.